Today on Real Garage, we're getting rid of all the holes in the firewall by making one big one. Okay, this is the closeout panel that will be joined to the firewall. Notice I didn't say welded, because for this project, I'll be using silicon bronze. Now this is a stamped piece that I got from Detroit Speed, and for about 90 bucks, it saved me a bunch of time from templating, cutting, and roll forming the edge. With it clamped in place, I'll mark the outline of the new plate so I can determine the area that I'll plasma cut out. I've already trimmed the new panel for the bay bar mounting flange. Some people just like to install the panel over the entire area, but I like gutting it first, for a couple reasons. First, it removes a few pounds of unneeded weight. And second, there's no good way to get the inside of these pieces fully primed and painted to protect from future rust. So for me, the inside one has to go. So here's my outside panel lines, but my cut lines are going to be a little bit less than that, especially on the top, because there's 3 overlapping panels there that are spot welded together. The first one is this top piece, and the middle one is the bottom that closes in this little vent pan, and then you have the outside firewall. Now this bottom one is a good bit lower than the top of my panel mark, and you don't want to cut into that. So your options would be, if you want to risk it, you could use an air cutoff wheel if you're really good at managing your cut depth. But for me, that extra lip isn't going to be a deal breaker, and the plasma cutter is a good bit faster than the air cutoff wheel anyway. Warning: read and follow all labels and your owner's manuals. I've marked my cut lines, but I'm starting my top cuts from the inside of the car to make sure that I only cut the firewall. My Spectrum 375 plasma cutter is set for 17 amps, and I'm using the torch with an exposed tip. This allows me to get into tighter areas and see my cut lines better. Cutting this thin gauge material is no problem without the drag shield. When cutting thicker material, however, the drag shield provides the proper tip standoff and arc length for optimized cutting and longer tip life. I'll clean up the cut zone a little bit with a sanding disc. And then some acetone to wipe off all the Sharpie lines. Then I'll fit the closeout panel back into position. Okay, like I said earlier, I'm not welding this panel in. I'm using silicon bronze, so technically it's a brazing process. Kinda sounds like a real scoop coming up. Working with silicon bronze can be done with the MIG and TIG process, and we actually refer to it as brazing, because welding would require that the base metals and filler metal be melted together, and you don't want that with silicon bronze. Silicon bronze is actually over 90% copper, And if you were to melt the base metal steels first and then add the silicon bronze filler metal, you would experience hot cracking of the weld joint. You really need to treat this more like soldering. Now, the advantages of silicon bronze is that it's very strong and easy to metal finish. Plus the fact that you're using about half the power to join the metals, it creates a lot less warping, since the silicon bronze melts at only 1800 degrees compared to, what, 2600 to 2900 degrees for mild steel. And for the artistic people out there, silicon bronze is excellent for joining dissimilar metals while creating a nice, attractive finish. MIG brazing is done with 100% argon gas, and I'm using 023 silicon bronze wire. Now, the Multimatic 220 AC/DC doesn't have programming for silicon bronze, so I'm setting the machine manually for 14.5 volts and 410 inches a minute of wire feed speed. A pulse MIG machine would be even better. Now, you can just do a straight stringer pass with this. Or a step weave pass works nice too. Or you could even just do a simple spot stitch pass. And sometimes your finish bead doesn't look that pretty, but after you metal finish it, it looks great. And here's an example of that. For this piece, I just used a simple spot stitch technique. And after metal finishing it, it turned out nice and smooth. I actually prefer TIG for this because it's much easier to control your heat, your filler metal deposition, and your speed. Normally, I'll do a bunch of sample pieces to get my amps set properly. I like to set the machine just under the point where it melts the base metal. And for this material, it turned out to be about 25 to 30 amps. This is a piece that I used the TIG process on. Notice that the bead is smaller and narrower, which makes my metal finishing much quicker. Joining metals with silicon bronze takes some practice, but after you get the hang of it, you'll definitely like your results. So I'm spot tacking the panel into position with MIG, and then I'll use the TIG process in between. I'll also use the MIG process when doing these bottom seams, which are really hard for me to get into, since the plate and half a dozen screws in my neck really limits my head movement. These are the times where I wish the car was still on my rotisserie. Then I could move it any which way I wanted. Going from MIG to TIG with the Multimatic 220 is no problem using the Quick Tech feature. Simply pull the trigger on the MIG gun or step on the foot pedal and the machine switches processes automatically. And it remembers my settings. But there's a catch. Using silicon bronze, I need 100% argon for both processes, which normally I would only need that for TIG. Here's a quick real gear tip on how I do this. The dual regulator flow meter from Miller is perfect for this. The part number is 23-50-580. 1 argon tank, 2 regulated flow rates. Just hook up one side to the MIG gas solenoid and set it for 30 cubic feet per hour. Then connect the other side to the TIG gas solenoid and set it for 20 cubic feet per hour. This also works great when using the Multimatic 220 AC/DC to MIG weld aluminum with a spool gun, while still being able to TIG weld. Another thing I like the dual regulator flow meter for is when I need to TIG weld with a back purge, like doing stainless tubing. Typically, the back purge is a much lower flow rate compared to the welding gas rate. As I do some of these long weld sequences, I sometimes reflect on how I got into building and racing cars. I will say this, I was told I had a need for speed since I could walk. I wore out more trike wheels as a toddler than my father would like to admit. He could change those things like it was a NASCAR pit stop. Then I actually remember a few years later, my father worked for 3M Corp, selling copy machines. He would bring some old ones home and I would tear them apart, get the motors and gears out, add a little string, then plug them hot into the wall and drag my army men and trucks across the floor like it was a big winch. I loved working with my hands and building things, or mostly tearing stuff apart. When I was in the 6th grade, we made a big move to another town. And to my delight, we moved next to a guy who had a race team, where they ran 3 or 4 cars out of. I would go over and clean the shop for a few bucks and get to watch and learn. By the time I turned 15, I built my first engine and bought my first car. 1976 orange Trans Am. And I've had many Trans Ams and Camaros since, which continues today with this first gen model. All right, I'm just about finished. I got a couple pinholes I need to go back over, and I need to put my beads around my bolt-in flanges. And it looks like I missed a spot on the bottom I gotta fill in too. Never said I was perfect. Otherwise, I think it's looking pretty good. Next time on Real Garage, I got a friend coming up to give me a hand. I'm falling a little behind on this project. We'll be working on modifying the trans tunnel and narrowing the back seat.